In this video, we're given another system which is in equilibrium, and our goal is to calculate the tensions in the two strings. So basically, you have this 10 kg block that is supported by two strings. The tensions are going to be called T1 and T2, and we want to calculate T1 and T2 in terms of the angles and in terms of the mass of the object and anything else that we might need. So the first thing you do is draw a free body diagram. So this would be a good time to pause and then go ahead, draw your free body diagram and then come back and check. All right, so assuming that you've done that, you've paused and you're coming back, I'm going to draw my free body diagram here. So first is we have the force of the earth on the object, which is its weight, which is going to be equal to 98 newtons. Then you have these two tensions pointing in this direction. One is say T1 and then the other one is say T2. Now, one key feature here is to recognize the angles. Okay, so this angle here would be 30 degrees, and then the angle here would be 53 degrees. So this would be an appropriate free body diagram. However, you notice that this free body diagram in the current state doesn't really help you solve the problem. So we need to do a few things to it, and for this we will use some of our vector information. So what you need to do first is again pause the video and find the components of the forces T1 and T2 along the x and along the y direction. So draw those components out, just like we did when we were dealing with vectors. Once you have the components, come back and take a look. Okay, so here's my picture of the components of the forces. So I'm just drawing this slightly larger. So I have 98 newtons here, and we had T1 here drawn. So what I'm going to do is I'm going to find the component of T1 along the horizontal. Okay, and if this angle is 30 degrees, then that component is going to be T1 cosine 30. And similarly, I can find the component of T1 along the vertical, which would make it T1 sine 30. Now we can do the same thing for T2 and draw the components of T2. So T2 is once again pointing out here, and it makes an angle of 53 degrees. So my vertical component of T2 would be T2 sine 53, and my horizontal component would be T2 cosine of 53. Now once you have this picture, we can basically just ignore T1 and T2 now and not worry about them and simply deal with all the components in the form that we have. Okay, so if we were to equate or set the x components equal to 0, we notice on this picture that clearly T1 cosine 30 and T2 cosine 53 are oppositely directed. So we could set up the equation T1 cosine of 30 minus T2 cosine of 53. All this is equal to 0. Similarly, we could set up an equation along the y direction, which once again, if you look at the picture, you see that T1, T2 sine 53 and T1 sine 53 are both pointing up, and then the 98 newtons is pointing down. And so we can write T2 sine of 53 minus T1, plus T1 sine of 30 minus 98. All this is equal to 0. Now, once we have this, the rest of the stuff is basically just doing the algebra out correctly. So we can take the first of these equations and set up, say, T1 in terms of T2. And if we were to do that, we would get T1 is equal to T2 cosine of 53 all over cosine of 30. And we can, substitute the values of cosine 53 and cosine 30. And I think you'll have something like T2 times cosine 53 is about 0.6. And then you divide this by cosine 30, which is about 0.866. Now we can take this value of T1 and substitute into equation 2. And what we'll have is T2 times sine 53, but sine 53 is approximately 0.8 plus all this T1 is T2 times 0.6 over 0.866, and then I have to multiply it by sine 30, which we all know is simply 0.5. And all this is equal to 98 newtons. So all I've done is I've moved the 98, on this side. So all this is equal to 98 newtons. And now this gives us an equation simply in terms of T2. So I get T2 times 0.8 plus 0.6 times 0.5 all over 0.866, and all this is equal to 98. And I'm quite certain that you guys can all finish this problem and get the answer in terms of this. Okay, so in this problem, oh, by the way, once you get T2, you can now substitute back into one of the equation into this equation, and then find T1 in terms of T2. So make sure that you understand this problem, because once you get this, then I think basically all equilibrium problems essentially, is some variation of what you've just done in this one.